All right, let's talk about section 9.4, circular and periodic functions. All right, so we are going to be talking about first this concept called the unit circle. Now, we've already talked about what happens when we think about points, angles that are created by points in the xy plane, okay? And we talked about like the length of this was r. That was the r value. We learned that in section 3. Okay, and in this situation with the unit circle, we're going to use a circle that is 1 unit long. One unit has a radius of 1 unit. Okay, so the distance from here in the center to the edge of the circle is 1. Now, if we do that, some interesting things happen in the circle, in the unit circle, with sine and cosine. So let me show you what those are. So I don't want to muddy up this picture here, but if I just quickly sketch a small unit circle here, and I pick any point out here, x and y, and that angle that's created, if we call that theta, then take sine, for instance. Sine of theta would be equal to the opposite side, which would be this. That length right there, would be y, over the radius, or this distance here, the hypotenuse, which would be 1. So we get y over 1. So we end up with this fact that sine of theta is equal to y. I guess we should write this a little more carefully. Okay, sine of theta is equal to y. All right, and the same thing can be said of cosine. Cosine of theta turns out to be equal to x. And then tangent is the slope of this line, which would be rise over run, which would be y over x, which would be sine over cosine. Okay, so these are all facts that come from the unit circle and can be used in different situations. Now, again, as I've mentioned before, if you go on to pre-calculus and you take trigonometry, you spend a lot more time learning about the unit circle. It's really quite fundamental and foundational to trigonometry. But for our purposes, the big takeaway here is that if you're analyzing inside of the unit circle, where the circle has a radius of 1 unit, then any x comma y can be written as cosine comma sine. Okay, so for example, if you have theta is 120, then cosine of 120 is the x value, and sine of 120 is the y value. Right? These are called circular functions, x equals cosine theta and y equals sine of theta, because they're defined using the unit circle. Okay, and theta is an angle, and y is dependent on an angle, and the angle occurs in the circle. All right. So let's do an example. How would this be applied here? We'll do an example. Okay, so the terminal side of an angle theta in standard position intersects the unit circle at 1/2 comma root 3 over 2. Find cosine and sine. Well, don't overcomplicate this. We know that any point on the unit circle can be written as cosine comma sine. In other words, this value right here, which is 1/2, is cosine of theta. This value right here, which is root 3 over 2, is sine of theta. And so we can write the answer. Cosine of theta is equal to 1 over 2. And sine of theta is equal to root 3 over 2. All right, and that's it. That's all we need to do. Okay, sometimes students get confused. They're like trying to find the angle. Like, no, we don't need to. We could, but we don't need to on this one. Okay, so. All right, number 2 here. Periodic functions, or the second concept is periodic functions. A periodic function is any function that has a piece of it that repeats over and over and over again, okay, at regular intervals. One complete pattern is called a cycle. All right, and the horizontal length of one cycle is called the period. All right, so let's look at this basic graph here. We have this repeating graph. It makes this V shape, and then the V shape repeats, right? So then it happens again, and this will just keep going as you move to the right, okay? So this pattern here is called one cycle, and then the length of the pattern is called the period. Okay, so in this case it goes from 0 to 360, all right, and so that is the period is 360 degrees. Okay, and that's the length of one to complete one cycle. Okay, so let's do an example here. Determine the period of the function below. Well, the function below here, you can see it has this repeating cycle, so it goes down, over, and up. And then it repeats again, down, over, and up. and it will just keep repeating despite the fact that this arrow is pointing down like it doesn't repeat. So it'll keep repeating. So I've already highlighted one cycle here, so this is one cycle. All right, and the period of this cycle is, it starts at x equals 0, and then it goes over to pi. So the period is pi. Pi units, okay, pi radian probably, but pi units long. Okay. All right, let's do a little word problem here. So here we've got data for height of a bicycle pedal at different time intervals, and we're going to plot the points. So we've got 0, at time equals 0, it's at 18 inches, so that'd be like right here. At time is 0.5, it's at 11. So 0.5 is at 11. And then at 1, it's at 4. It's down here. 1.5, it's at 11 again. You can start to see the cycle here. At 2, it's at 18 again. And then back down to 11 at 2.5. And then back down to 4, and so on. Now, you might be inclined to draw like a zigzag, but this is probably actually going to be more like a kind of a curvy-like line, okay? Because you don't pedal in a kind of jerky motion. It's just a smooth motion, okay? Around and around. And so we look at this and we figure out, okay, well, what is one complete cycle? Well, it starts off here at 18. It goes down, comes back up, and then it's back at 18. So the question is, there's one cycle. And I guess I didn't ask a question explicitly here, but we can figure out what the length of it is. In other words, what the period of that cycle is. It's going to be 2 seconds. So the period is equal to 2 seconds. Okay. All right, cool. Last concept here, looking at the unit circle. Okay, so the unit circle here, I have listed out all of the angles that are intervals of 15 degrees, and then also, I'm sorry, all the kind of the significant angles, so 0, 90, and then 30, 45, 60. All right, and I've listed all of the XY points here. Okay, so this is really helpful for figuring out questions like sine of 270. So if you want to know the sine of 270, again, remember that x comma y, there's a good place to write this, x comma y is the same as, in the unit circle that is the same as sine cosine. Oh, sorry, cosine sine. Cosine of theta, comma sine theta. Okay, so if you want to know sine of 270, you come over here, you go to 270 on the chart, you see that 270 is right here, and here is your cosine value, that's 0, and sine is -1, that's sine right there. Sine of 270. So sine of 270 is equal to -1. Now you could have done these problems using the 3-step process that we learned in section 3, but you don't need to. You can just use the unit circle that I provided you here to figure it out quicker. Right? So cosine of 480. So let's check. Cosine of 480. So going around 360 would be here. Then we need to go around another 120 degrees. So that would be to right here. So here's 120. I want cosine, so I'm going to look at the x-coordinate there. The x-coordinate is -1/2. So cosine of 200, where did I get 240? Cosine of 480 is equal to -1/2. Try the next one and see how it goes. So we're looking at 11 pi over 4. And 11 pi over 4 for most students is going to be easier to think about that in degrees. So let's quickly convert that to degrees. So we've got 11 pi over 4 radians. And then we're going to put pi radians on the bottom and 180 degrees on top. So I've got pi and radians all cancel out. 11 times 180 over 4. $495 degrees. Okay, so 495, if we take 495 and we take away a full circle, that'd be 135. So I come over here to the unit circle, all the way around to be 360, plus another 135. to get to here, and we want to know the sign. The sign would be the y coordinate, which is root 2 over 2. Okay, so we can write that sine of 11 pi over 4 is equal to the square root of 2 over 2. Okay, so a little bit quicker than that 4-step process. Again, in trig, in pre-calc, we'll go more in depth on how to generate this thing and where all these numbers come from. But the basic idea is that the unit circle is really powerful because you can identify these values without doing the 3-step process. And that is it for section 3.